This conference will now be recorded.
Yeah, good morning all. So today's class is all about something called JVM. Okay, so if we go back to our course content, we have already covered the section 1 and section 2 and all the practicals for Linux and Mon utilities and the Puffmon metrics, everything has been shown in the last sessions if you remember. And we are starting with the section 3, which is Java Performance Engineering, basic level and advanced level. So we will talk about all the different things that I have mentioned here, like what is JVM, the JVM, the different components that we have in JVM, and how does a JVM work. So it is not really necessary to understand the complete end-to-end working of JVM, as you're not a Java programmer, but you need to understand few basic things from a JVM side uh, to understand from where you can see multiple bottlenecks, from what different places you see performance degradations with all the Java applications that are being executed using something called Java Virtual Machine. Okay, so we talk about different types of JVM and some basic level of architectural internals, architectural components, and most important part here is we have various memory areas in JVM, like method area, heap area, stack area, PC registers, and native method stacks. So we are mainly dealing with heap area, where it contains all the object data information. This is the place where objects and corresponding instance variables will be saved. So we continuously check the utilizations and allocations of the memory that is being allocated to various objects in a Java program every time it is executed. So, and before explaining all these different components from the JVM, everyone must be aware of a simple Java program structure, right? Are you aware of that? So, what is package? What is class? What is method? And what is an object? Do you know the hierarchy of the structure of a Java program? Anyone?
Yes, I know that's Sridhar.
Okay, okay, okay. So I'll explain you some basics of that. Okay, and again we will talk more about the GC logs analysis, major GC, minor GC, how often the GC runs. So what are the different problems that you see if you have so much of GC past time? Why user application? Your application can hang literally for 2 seconds when there is a GC happening? Different GC algorithms like G1 GC, CMS, concurrent mark and sweep, parallel, serial GC, and there are other phases that are involved from GC side, uh, mark, sweep, and compaction, which is also called delete. So after that, you will also talk about JVM performance monitoring, Java performance optimization. What are the different metrics that you need to see to check the health and behavior of JVM? And you have various profiling tools like Java Profiler, JVisual VM, JConsole, JProbe. You also have App Perfect profiling tool, which is available for Java. So likewise, you also have some command prompt utilities where you can directly take a heap dump and thread them by using something called process IDs. And there is a tool called MAT, which is called memory analyzer tool, which will directly check the usage of all the different used objects, unused objects, dead objects. It will directly give you the pie chart diagrammatic representation of all the utilizations of the JVM, of all the objects, variables, all the different data that is there from, inside the JVM when it is executed. Okay. So after that, we'll talk about thread dumps, heap dumps. Most importantly, everyone's common issue is the out of memory leak with respect to memory. So how do we deal with the JVM out of memory errors, application performance issues due to memory constraints, and some case studies on how to fix all these out of memory issues. Okay, so this is all about. We'll talk about the section 5 later. So okay, so this is the basic architecture diagram of the JVM. So now here when I say JVM, right? What I mean, what I am going to explain here in JVM is roughly a basic idea, as we are all the performance engineers at a very high level, and I'll explain the overview of JVM. And as I told you, it is not really required to understand every place of JVM, every component JVM in depth, because it is most of the areas are required for a full stack developer who works in end-to-end Java applications development. So, and you may feel like the terminology is totally new with respect to some of the components. But at the end of this session, you will understand at least the basics of JVM and how does a JVM will work, and what exactly will happen in JVM when a program is being executed. Okay, the basic agenda. So before we start, could you tell me what is virtual machine? Anyone?
A virtual machine is Java's unique design to achieve the platform independency.
Right. Okay.
Different VMs are available for different OS, so Java program can run on multiple operating systems.
Okay. Any other answers?
It's a mission exclusively with Java, and it's a virtual, as if it works as a mission and executing end-to-end the application, the Java application, since from class loader to until the execution to the operating system.
Okay. So virtual machine is nothing but, I don't say it as which is not really existing, but which is not original and physical. For example, if you take you have virtual classrooms, virtual memory, etc. Right? So if you take a physical calculator, for example, you can see you can define the weight, size, and the look and feel of that calculator, the physical one. But when you even if you take the mobile, it is a physical device, right? But when you come to calculator, you have a software program where that is available for every Windows machine. You can open run command and you can simply type CALC, and it opens the software program that is developed and that is working in your everyone's laptop. So we cannot tell the size or weight of that particular calculator, but what it does is it does the same functionality like a physical calculator. Likewise, you have something called JVM, which is a Java virtual machine. What it can do is it is just a software simulation of a machine which can perform operations like any other physical machine. It is a platform independent. You can run this JVM on, you can have this JVM on any of your operating system. It is a platform independent, operating system independent, and you can do all the simulation of a machine which can perform all these operations like you do it in physical machine. Okay, and when you come to these virtual machines, basically you have two types of virtual machines. One is hardware based virtual machine, and one is the application based virtual machine. So basically these hardware based virtual machines are also called system based virtual machines. Like if you look at the system based hardware based virtual machines, the popular course about the hardware VMs is something like VMware. Okay, so you will have one physical server like an ESX server, and in one physical server you will have some 6 logical servers. It means that for example, cloud computing, if I want to create one environment, I get one simple machine, a logical server, sorry, physical server, which sits in some data center. I break that into bits and pieces with respect to the configuration that I need in terms of memory and CPU. I'll define 4 cores, 8 cores, 12 cores, and 4 GB, 8 GB, and different RAM. Okay, so you have something like VMware and also called KVM, kernel-based virtual machines. So these are all hardware-based related virtual machines, which are also called system-based. Okay, basically within the same computer, we can provide several logical systems with strong isolation to each other. That means that there is no dependency uh, on each of, I mean, for every logical machine that we define in a physical server, it works independently again. For example, if you have one physical server where I have some 6 logical servers I defined with respect to my configuration, uh, the machine 1 is being used by user 1 and the machine 2 is being used by user 2. Likewise, machine 6 until machine 6 is used by user 6. But in the end, in the last, all the users are communicating to the same machine, which is again a physical server. Okay, this basically happens in cloud computing. You will get one server, you will break that into different pieces, some like 4 Windows or 2 CentOS or 1 Red Hat, and you select the configurations accordingly, and you split all the configurations. So what will happen here is, the advantage of using this approach is all the hardware resources sharing will happen. Okay, and here, can you mute your lines, please? I am hearing some kind of disturbance. Can all of you mute your lines? Okay, thank you. So when you use this cloud computing kind of a concept, right, like this approach, all the resources on this physical server will be shared. When you are adding some logical CPUs to it, it is 1, it can be 3, it can be 6, depending upon your configuration. So using the physical server in this way will improve the utilization of resources. But when coming to the performance testing practices, right, every time you set an environment, that you ask the client, do I need to run all this test on a virtual environment which sits on all the VMs, or do you have something like an on-premise setup where I can get a physical servers of each instance? Like, you give me some machines, we will create some lab where we can set up the web server, app server, and database server, and we measure the actual performance. But when you try to do this on a virtual environment in a cloud, any cloud, you will see too many latency issues. You will see some connectivity issues, depending upon in which place the machines are hosted. Where is your data center hosted? This all matters when we again talk about performance. So every time we want to test something in terms of performance, load testings, or different flavors of performance testings that we conduct, so we always keep asking the client on what is the place we intend to conduct the test, the load test. Okay, so after there are so many fixes from the AWS and Azure. That is why the reason people started moving to cloud, and they're executing or performing all the load tests on virtual machines itself. Okay, and for this hardware-based VMs, right, which are also called system-based VMs, no program is associated with these hardware-based machines. All the admins, okay, cloud admins or VMware admins or ES6 server admins, there are like Zen. Zen is another vendor. All these admins will take care of these activities to maintain, to install, to break this into different logical CPUs. This is basically an admin job, Azure admin, AWS admin, and all other admins job. Okay. So when we talk about application-based VMs, right, these are basically called. This is a second type. These are basically called process-based VMs. That means that these process-based VMs, they acts as a runtime engine to run a particular programming language of that application. If you take JVM, that is an application based. Okay, if you, for example, you have JVM. Now tell me at a very high level, tell me what is JVM? Anyone? It can be a one line or it can. Yeah.
You have the class loader where the application is loading, and then you have the stack area where all the memory allocations, whether it could be heap, method, or even the TCP registers.
No, let us not go in depth. So I'm just asking you at a very high level.
Okay.
What is JVM, and I mean, for what reason we can use it? What is the functionality of the JVM, or what exactly is JVM?
JVM is like a logical CPU, as you mentioned. It's like a software program, but it gives the functionality like a CPU, and it has the Java runtime environment, so in which Java programs can be executed.
Okay. Any other answers?
It will convert the class file or program into a local machine language.
Okay.
It executes as a high level. It executes the Java application end to end with the help of a native operating system.
So yeah, thank you all. So basically, when I say JVM, right, it acts as a runtime engine to run all the Java-based applications. Simple. Okay. So you need some runtime engine, right? If you write some program, or if you have some package, if you have some multiple methods and multiple objects that are there in a program with lot many variables or constructors or modifiers in the program, if you want to execute that, you need some memory, you need some engine which can combine all the bytecode instructions, which can convert all of them into understanding format, and it will get executed. It will take all the inputs that we have defined in the program, it get executed, and it gets compiled, and it gives you the output. So to run all of that area, to run all of that piece of code, you need a JVM, okay, which acts as a runtime engine to run a particular programming language. Not a particular, in here, a particular programming language is nothing but Java. For all the Java-based applications that are developed in Java, so JVM is a very popular virtual machine, which is a runtime engine to run all the Java-based applications. There is also called PVM. This is called parrot-based VM, parrot-based virtual VM. Like in Java, like JVM is a runtime engine for all the Java-based applications. For PVM, this acts as a runtime engine to run any scripting language applications. For example, if you take Perl-based application, right, any scripting-based application, PVM is required to run that scripting-based applications. PVM basically acts as a runtime engine to run any application which is developed on some kind of scripting application. And if you go to CLR is another powerful runtime engine which is basically used for .NET-based applications, called Common Language Runtime, and this acts as a runtime engine to execute all the .NET-based application. This is also powerful like JVM. So for all the .NET-based applications, this CLR runtime engine is used. Okay. So any questions still here? And you have to install JDK. JVM is a part of JRE, Java Runtime Environment, and JRE, Java Runtime Environment, is a part of JDK. I would request all of you to install JDK along with JRE, which installs everything. Okay. And before we proceed, I don't want to load much today because these are all basics. We'll go slowly. Okay. And we spoke about, if you look at the diagram now, if you look at the diagram now, the first component of JVM is class loader system. Basically, this class loader system is responsible for three main activities. One is called loading. If you look at the second one, the second one is linking, and the third one is initialization. For this class loader subsystem, right, dot class file is an input file, for this class loader subsystem. Okay, and if you look at if you look at the class loader subsystem, right, there are three types of class loaders. One is bootstrap class loader. In the first box, if you can see in the class loader system, the second one is extension class loader, and is application class loader. Okay, and I'll tell you how a class loader will work and what is the need of it. You need not understand the need or use of a customized class loader. You can also, if you're a full stack Java developer, in practices, right, as a part of development practices, there is some pseudocode for defining the customized class loader. Apart from this bootstrap class loader and extension class loader, right, application class loader, you can also define something called customized class loader, and there is some pseudocode for that. And if you go to the second part of second module of JVM, I'm talking about the second box in the JVM architecture here. These are all the various memory areas that we have inside the JVM. The first one is method area, and the second box is heap area, and the third one is called stack area. The fourth one is PC registers, and the last one is native method stack. Okay, and there is a simple program. If anyone of you have some hands-on experience in Java, you can write a simple program to display the heap memory statistics. If you have some knowledge, you can write some basic programs, and you will also see the heap utilizations or the defined heap numbers by using some program. You can run that, and right, how to set minimum and maximum heap size like XMX and XMS values. In these areas, right, the most important part as a performance engineer that we deal with is the heap area, and heap area has got different areas in it, like young generation, Eden, on heap, PermGen, Metaspace. There are other different areas inside the heap. So every time when some load testing is happening on an application with lots of user base and user load, the only primary thing that we monitor is the heap area. We continuously take the heap dumps. We will try to analyze the complete memory statistics, and we'll try to understand how the heap is being used, okay, in each and every different area. How the object allocations is happening, how the GC is happening. So whether it is removing all the unreferenced objects, whether it is storing all the reachable objects, which are called live objects. So all you keep checking all these activities on heap. Okay, so this is the main part that we focus when we talk about this heap area. Okay, and when we talk about the execution engine, after allocating the memory, it comes to the execution engine. You have something called interpreter in that, and you have JIT compiler, where it will conduct a few steps there, like code optimizer, target code generator, and profiler, and you have a garbage collection here. After that, there is something called native method interface and native method library. Okay, so there is also a basic diagram. Let me open that. Before going into main diagram, I have downloaded a screenshot. Are you able to see it? You're not able to see it, right? Is it better now?
Yes.
No, it is simple basic architecture. It is simply saying the class loader, the JVM memory areas, execution engine, native method interface, and native method libraries. It is not talking about, again, it is not going in depth. Like it is not talking about the components, that individual components that we have in execution engine or class loader, types of class loaders. It is not talking all about that. Okay. So as I told you, class loader subsystem is mainly responsible for three different activities. One is loading, linking, and initialization. Okay. So basically, I have let's say that I have a .java file. Okay, a simple .java file. So I compiled it. After the compilation, the .class file will be generated. Initially, I have a .java file, and after compiling it, I'll get a .class file. So this .class file, after compiling, the first time it gets saved into the hard disk. Okay, not in any of, you have to remember again, not in any of the memory areas of JVM. Okay, it's stored in the hard disk. So now we have to read this .class file, and you have to load this .class file into JVM memory.
Question.
Yes, please.
When we are converting Java to .class file, right? That is nothing to do with our JVM. It is done by compiler, right?
Right. All the conversions will be taken care by JVM. You need not do anything here.
Because when we see the class loader, thought that your class file, the bytecode starts from here. That means the .class file previously is being compiled and get ready to load into class loader.
Right. So all the conversions that happen inside the JVM will be completely taken care by JVM. You got nothing to do with that. So whatever the .java file, when you compile it, it automatically converts into .class file. Simple.
Right. That's what my question was. Yeah. When we are compiling, I thought that is nothing to do with the JVM. It is something with the compiler.
No, yes. Nothing to do with JVM. Nothing to do with JVM. I'm just trying to explain what will happen here. That's all.
Okay. Gotcha.
Okay. So now so whatever the .class file, that .class file will act as an input, and it loads into the Java memory area. It loads into the method area, which is the first memory area. If you look at all the 5 various memory areas that we have inside the JVM in runtime data areas, the first box is method area, which is the first memory of the JVM. Okay. What will happen here is it reads the .class file. I mean, it reads all the class binary level. It will store all the information of that in method area. Okay. And you must be having a question for every .class file. What are all the other things the JVM is going to store? So what are all the other things that the JVM is going to store of a .class file? What do you have in a .class file? Or what do you know about .java file?
It's the entire bytecode.
Let me explain you at a very high level. So you can create packages if you want to use some multiple objects, multiple functions. You can create packages. That is one point. So we'll keep the packages aside for now. The first thing that you do is you define a class, the basic hierarchy of a program. Okay. After that, you define method. One class can have multiple methods. Okay. Method is nothing but the actual functionality that it has to do, the functional task. Okay. And the object, sorry, for after method, you can create something called object, and each method can have multiple objects. So the first part is you define a class, then the second part is define method, then you define object. So after writing some piece of code, the complete program, it gets saved in .java file. When you compile it, it automatically converts the .java file into .class file. Okay. So that .class file is being executed by JVM. So for the very first time after the compilation, it gets stored in the hard disk. Okay. When we talk about something called loading, what it does is the dot class file will be an input for the class loader system. It loads into the JVM memory area, which is the first area called method area. So in this method area, what it will happen is after reading this dot class file, it will read all the class level, binary level information, and it stores in the method area. Now, what question I asked is, for every dot class file, what are all the other parameters of that dot class file are being stored in method area? So what it will store is, it will store the complete information of a dot class file, okay, in the method area, like fully qualified name of a class, or fully qualified name of, for example, the complete methods information, the complete variables information, the constructor information or modifier information. Likewise, whatever that you write the inputs as a part of a program, all the information will be stored in the method area. Okay, so we have three different things here. One is bootstrap. After loading, I forgot to tell you. So after loading this dot class file, JVM creates an object of type class to represent that file in the heap area. So that class file will be converted into object level information in heap area, and that conversion will happen by JVM. You need not worry about how this conversion will happen. Whatever the dot class file that is stored in method area with all the complete information, when that comes to the heap area, it directly JVM creates an object type of class to represent this file in heap memory, because in the heap memory everything is stored in like objects. So it's something called objects. It allocates memory, and you have different type of objects. So these are all the classes and all the objects, right? This type of class is already predefined by something called java.lang.package. So this class object can be used by any programmer for getting all the class level information, like as I told you, the methods, variable information, the parent name, the qualified name of that class, all this information you can retrieve by using this package. Okay, so when we talk about this bootstrap class loader, this I don't think so this is required. I don't want even explain you much on this bootstrap class loader. Okay, well, let us, class loader will have you can just go through this link. I'll send it to you. What is a bootstrap class loader and extension class loader and application class loader? This class loader, bootstrap class loader, there is a separate class loader for all the bootstrap path. And if you have any additional extensions, right, from the extensions path of bootstrap class loader, it will load all the dot class files. And the application class loader, there is a different path where it will consider all these dot class files to take that as an input and to run it. So you need not worry about all the detailed information of the different class loaders. And as I told you, you can also, the programmer can also create the customized class loader with some pseudocode, which is not really required from a performance testing side. And we immediately, the next step is something called linking. In linking, what will happen here is it will mainly performs three different steps. One is verify, one is prepare, and one is resolve. So if you remember, if you have some experience with any of the C programs, right? When you try to run that C program in any of the machine, I'm not sure how many of you have seen this error, something like some message, not error, saying that when you try to run, you see a pop-up saying that if you want to run this, it may harm your computer, or this file will harm your computer, and it shows it will ask you for a scan if your antivirus is installed. But inside the JVM, right, you will not have such messages or pop-ups when you try to run something. This is called ORA, right? Write once and run anywhere. WORA. You can write once and you can run anywhere. It means that inside JVM there is a component called bytecode verifier. So whatever the dot class file that we have written, okay, dot Java file, when it is converted to dot class file with all the relevant information, complete information that is stored in method area. So what this bytecode verifier will do is it will verify that dot class file, like is it really valid, or is it generated by a valid compiler or not. So here everything is verified basically by a bytecode verifier. And if something is not there are some viruses, right, which can be sent as dot class files. Okay, even if you see in many of the WhatsApp messages, click to see what happens when you click that. It will open an image saying that Happy New Year or Merry Christmas or something. Likewise, you get some dot class files in the organizations with your organization name itself, like if it is corporate TCS at something dot tcs.com saying that run this class file or run this component to update your VM information or to update your personal information. If you run that, so immediately some attack will happen and the system may go down. So that is why the reason something like bytecode verifier, which is an internal component of JVM, which resides inside the JVM, it will the first thing it will identify is this generated by a valid compiler. Does this have some structured programming? Is this valid? That is how it is valid. After completing, it verifies the dot class files and it will ensure that all the binary.
Okay, your voice is fading.
No, I mean, I'm sorry. From how long? This is happening only from the last 2 minutes or 10 minutes?
10 minutes.
Okay, so I'll repeat it for you then. In the verify, there is something called there is a component called bytecode verifier. Okay, inside the JVM. What I mean to explain here is basically when you write something in C program, when you try to run on any machine, right? I mean, there are situations where multiple users have seen some pop-up messages saying that if you run this particular program or something, it is harmful it is harmful to your computer or to your machine. The reason is because that particular program has not been verified. So that is why the reason it will give you that pop-up. But when you come to this Java, the JVM concepts, basically this Java is written in Aura concept, right? Write once, run anywhere. So this bytecode verifier will verify the dot class file. Whatever the dot class file is there is available. It will verify is it is it valid or is it generated by valid compiler. Okay, everything is verified by something called bytecode verifier. And if something is not being verified, if it is not able to verify that particular dot class file, you will get something called verifier error. It means that the bytecode verifier is not able to read or verify that dot class file, and it is asking you not to execute this dot class file. Okay, so this bytecode verifier is very reliable inside JVM to identify this verifier errors, and and this bytecode verifier, what what it will do is it will ensure that the binary representation of a class is structurally correct or not. Okay, it will check whether the dot class file is generated by a valid compiler or not. It is very simple. Okay, so that is how the linking will work. Okay, so preparation is nothing but JVM allocates memory for all the class variables, and it will initialize the memory to default values for all the dot class files. Okay, so this is nothing but preparation, and this is the third phase. The third point, resolve or resolution. It is also called resolutions. So what it will do is it will take care of some references from the type there are something called references concept. It is done by searching method area to locate the referenced entity. Again, we will talk more about that when in heap dump heap areas, when we explain the heap areas about the referenced objects and unreferenced objects, live dead objects. I'll explain you there. So it will have some references from the type, the direct references, and it will search the method area to locate that referenced entity. Okay. So in the initialization part, this is the phase where all the static variables in the program in the class file are assigned to their values defined in the code. As per the code, whatever the static values you have, those are all the static variables are assigned with their default values. Okay, this is executed from top to bottom in a class, and this is how the initialization and assigning of values will happen of all the static variables. Okay, do not break your head with all these concepts, but I'm trying to explain you what will happen with each component here. You don't really need all this information, but when you work on a multi-based JVM environment where you have some entire architecture, you have to monitor all the JVMs and you need to identify all the abnormalities with respect to JVM. Okay.
1 second, RK. There is a disturbance from Anil. I wanted him to go on mute.
Yeah, please. So if everyone is on mute, so that so everyone can hear a clear voice from my side. Okay, please place your calls on mute, and if you have any questions, you can unmute and you can ask me anytime. Okay, as I told you, bootstrap class loader and extension class loader, application class loader of the three types. I'll share you one link that is very well written with a very nice explanation. So go through that link and it will explain each and every individual component. Okay, so now it is the main point here. It is called method. I'll explain you at a very high level. So you have a method area, right? These are all the 5 different areas that we have. This is a module 2. This is all the 5 different memory areas that we have inside the JVM. And so I would like to make a point here. So if you don't hear my voice, you can let me know then and there so that I can repeat it for you once again. Okay. If any one of you are not able to hear my voice properly, you can ask me that. I mean, again, I can repeat that. I have some network issues. So basically, when I talk about method area, right, all at one single point about method area. So all the class level data will be here in this method area. All the class level information, class level data will be stored here in method area. That's all. Only understand that. So you can do the
Okay, sir.
Sorry.
Your voice is fading again. Sometime.
Give me a minute. Minutes and nothing. Hello.
Okay.
One moment. Is it better now?
Yeah.
Hey, thanks, man. So yeah. So I'm talking about the 5 memory areas that are available here in inside the JVM. So when I say method area, we will forget about the remaining points and other stuff, as we are not here to learn all the full stack development course. So I'm explaining you the overall high level overview information of the basic functionality of JVM. So when I say method area, what you have to remember here is method area will have all the class level data. What this class level data will have, as I told you just now, it will have all the complete information of a dart class file. Like you will have the fully qualified name of a class, fully qualified name of a parent, methods information, variables information, the constructors information, modifiers information, whatever the different inputs that you have defined, variables that you have defined inside the program. When it is being converted, when the .java class is .java file is converted to .class files, it will store all the information of that .class file, and everything will be saved in method area. Okay, when this .class file class level information, right, it will contain all the corresponding static variables of that .class file, and it will be saved in the method area. And also the common values like constant values for a complete program will be saved in method area. It means, again, in a one line, the complete information of .class file are available in method area. This is called class level data. Okay, when it comes to heap area, all the class level data is converted into object level data, and the conversion from method area to heap area, which is the class level data to object level data, this conversion will be taken care by JVM. Please note. Again, don't break your head. The conversion, the .class file is there in method area, and that .class level data has to come to heap area to allocate all the memory. When the .class level data information comes to heap area, that complete .class level information is converted to object level data. So this conversion will happen inside the JVM internally. You got to do nothing with it. So all the objects and corresponding instance variables of this object level information will be saved in the heap area, and you have many different heap areas, many memory areas, different memory areas in heap area. We'll talk about in the next upcoming classes. Okay, so when I talk about stack area, stack area will have all the thread level information. The complete thread level information will be stored in the stack area. Okay, each entry for every thread you will have unique stack frame. If you see in the stack area, for every thread you have in the stack area, you will have a unique stack frame. And what is LVA? That is nothing but local variable array. And the second one is OS, operand stack, and the third one is FD. Right, FD is frame data. So basically, each entry in the stack area is called stack frame. I am telling you in one line. Okay, I am not going through all the different PPTs or slide. So basically, the stack area will contain all the thread level information, and each thread for each entry in the stack area is called stack frame. And every stack frame area contains 3 areas. One is local variable array, frame data, and operand stack. And for every thread, a separate stack will be there. Okay, stack means all local variables will be stored in the corresponding runtime stack. This is a very overview. If you can, if you want to do more R&D, or if you want to understand more on this area, you can go and spend some time on JVM, on understanding the JVM. There are some 2 to 3 hours video which will explain all this area. Again, it will start from right from the basics of Java. Okay, so what I meant to say here is stack area will basically have a thread level information, and each entry in the stack area is called stack frame, and every stack frame will have 3 areas as shown in the diagram. One is a LVA, local variable array, operand stack and frame stack frame. Sorry, frame data. So for every thread, a separate stack will be there, and all local variables of this stack will be stored in the corresponding runtime of that particular stack. Okay, this is where you will have all the thread level information. When you talk about PC registers, right, for every thread that you have in stack area, there is a separate unique PC register. There, for every thread, there is a PC register that is created. If you look in the diagram, PC register for thread 1, PC register for thread 2, and PC register for thread 10. It means that for every thread that is there in stack area, there is a PC register that is already created. What it will do is that this PC register will hold the address of the current executing instruction. Okay, for every thread, all the instructions, the next instruction is also available in all the instructions level information of every thread is holded. I mean it will hold all the information, the instructions of every thread in the PC register. Okay, and this native method stack, for every thread, again a separate native method area is created. This is the second module, the different areas you have in memory areas, 5 different memory areas inside the JVM. Sorry, I forgot to tell you, I have a severe throat infection. Please ask me again if my voice is not clear, or if you don't understand it when I explain it to you. You can ask me, or you can ask me to repeat anytime. So if my voice is not clear, or if you feel something is missing when I explain, okay? So the third module, if you see the execution engine, two things. One single line execution engine is responsible for executing the program, whatever the data from class level, object level, all the information from thread level, the memory allocations level, instructions level, the native method stack, everything, right? So execution engine is required to execute your program. Again, you have different parts here. The reason is because here JVM internally optimizes the program with respect to performance to some extent, not completely again. Okay, for example, if you have interpreter, right, what interpreter will do is we have a single method, or we have multiple methods to call and to get them executed. So for example, if I am calling one single method for multiple times, okay, one single method for multiple times without interpreter, that method cannot be executed. Every method I call from a program, if I want to get that executed, every time to get that method, single method, if I call it for once, or if I call it for multiple times, doesn't matter. Every time if I want to call that particular method, and if I want to get that executed, interpreter is required to run all that methods and classes. Okay, when interpreter will take care of all the of every method, of every object, every class, this is required, it will identify and it will run, it will execute. So there is something called JIT compiler. So this is basically used to improve the performance of the system. Okay, so, and there is another concept, like you can generate a machine code directly once where no interpreter is required. That is an advanced concept of Java. So every time you call interpreter to run every single method, or say every single class multiple times, or for a single time, the execution time is increasing, right? Every time interpreter is coming into picture, it means that it is identifying every single method, and it is taking some time for execution. It is spending some time for executing the program. So again, you have 3 concepts in JIT compiler: intermediate code compiler, which will produce some I see individual code. I don't know what exactly is that. I forgot intermediate code generator. You can go through the link, but code optimizer, what it will do is it will optimize the code with respect to performance. And the target code generator, it will generate the machine or native code, and after that there are some profilers which will take care of some profiling activities, and it will go into something called garbage collection. I'll tell you what exactly is garbage collection when we talk about this garbage collection techniques, minor GC, major GC, different ways of GC, and I'll tell you all of them. And if you see here, native method libraries, right? Some programs really require this native method libraries, and native method interface is responsible for providing all the native method information. That's all. This is all about the JVM, and if you look at this, sorry, I'll close this part. So this is clearly explained what verify will do, prepare will do, and you can understand about every individual part that we have in JVM to some extent. But if I talk about operand stack, if any intermediate option is required to perform, operand stack acts as runtime workspace to perform the operation. Now you should know what is operand stack. If you want to know what is operand stack, again you have to start Java basics, right? So there is something called I'll share you one video in the group today, the JVM architecture and how the JVM will work. So I'll share you 1 to 2 PPTs. I have some PPTs here. JVM architecture, not this one. So go through the JVM architecture, and again from a performance testing side, when we are coming to the profiling part, we see the class level information, object level information, and method level information, and we try to identify how each method is actually behaving. We'll ensure that if it is consuming more amount of memory, CPU, and we take a multiple snaps of heap dump and thread dump, and you cannot directly fix it as you're not a full stack Java developer. You sit with the development team and you try to understand what are all the different methods or classes or objects that are taking high amount of different memory and CPU process related tasks, and accordingly you understand what has been fixed. You can get in touch base with the different teams, and you write that in the report saying what improved with what. Okay, so we need to mainly focus about the profiling when it comes to engineering. JProfiler, JProbe is okay, and all other profiling tools, and the heap area basically. You have different heap areas in like Eden, young generation, old generation, metaspace, objects. So there is a lot of other concepts we will talk about maybe tomorrow, and this week we'll completely talk about JVM and Java performance tuning. Okay, and also we have I have written an article. If you go back to my LinkedIn, you have JVM, Java performance tuning, JVM monitoring. You have 2 different articles. You can directly go to my wall, and you can go through that articles. Okay, so any questions you have?
Yeah, RK. So when the JVM, when it converts bytecode into the machine code, and then it handovers to operating system to display.
See, that is what I am trying to tell you here. You have many different components that are available depending upon the type class file that you have. That is why the reason you also have class loaders, bootstrap, extension, and application class loader. So everything will happen internally. Like it will read the bytecode instructions and whatever the file that you have, it loads, it allocates the memory, it gets executed. And if something is missing from any other libraries, it will take the necessary file from that native libraries and it will try to execute that .class file. So what I want to tell you here is, even if you want to understand the depth of it, again, it will talk about so many other parameters, so much of other stuff from Java side. So basically, whatever you have said is right. I mean, it basically you will have a .class Java file, then it converts to .class file, and it goes to the JVM. It gets executed on top of operating system, and you will get the output. But what you have to see is how the areas are being properly utilized with respect to heap. That's all. That is the only limitation from performance side.
In the method area, right? So when you mention the class information, means the entire the class structure, that's going to, of course, local variable should be in another area. I understand that, but the entire class structure, the method declaration, whatever the code you see that, right? That is going to store in the method area.
Right.
Okay.
When I say the class level data, the total information of that class level, the class file, I told you, right? Method information, variables information. If you have some runtime information, constructor information, if you have any modifier information, there are, if you talk like that, you have some 20 to 25 informations, what you write, what you declare in the program, all that information will be stored in method area of that class file. Okay. So I'll share you this video. Okay. One moment.
This
Okay,
conference
so,
will now be recorded.
oh my God, what happened?